So the discussion today will be about angular displacement with regards to transformer connections. So any word which in English, any word, it has a root in English. That is, the words which we use, be them technical terminologies. Usually in this context, we're talking about technical terminologies. They have a word for them in English. So usually in the dictionary definition, so what we'll do is we will break the word or the compound term angular displacement down. So angular basically means measured by an angle. That's what angular means. These are dictionary definitions. The term displacement means the movement of a thing from its original place. So by that, we have as an example, to illustrate angular displacement, literally what angular displacement means, we have a circle. We know that a circle has 360 degrees. It contains 360 degrees. That is a full rotation. So any rotation which happens will be within the 360 degrees. Now, we will use this illustration to break down the literal definition. So, the movement of a thing from its original place. In this situation, the thing is going to be this line, which we have denoted it to be line A. And that is the movement of line A from its original place. So the original place of line A is going to be at this position. We will consider this position to be 0 degrees. When line A is shifted, or if you will, moved from its original place to this position, that is considered displacement. Angular comes from the way we measure this displacement. And the way that this displacement is measured is in terms of degrees. So from 0 degrees, this has moved approximately 30 degrees. So that means this angle is going to be 30 degrees. So with that being said, it means the angular displacement is 30 degrees. That is the angular displacement of line A to line A prime is going to be 30 degrees. So A is the original line. A prime is going to be the displaced line. So meaning that it is as if you have moved. So in that case, we would consider this to be a rotation moved in this way about a fixed point, which we're going to consider this to be a fixed point. So we're not talking about this, for instance. Angular displacement is the movement of this line, which is the initial line of A, about a fixed point. So the angular displacement could be 30 degrees, it could be 90, it could be 180, it could be, for instance, any other degree here. We will just stick with, for for this example, 0 degrees as the initial place, the original place, which is at 0 degrees, to the into the other place, which would be the a movement from its original place to the 30-degree mark. By this, we have that basically the definition literally of angular displacement is basically the measure of an angle, basically the movement of a thing from its original place, measuring it by an angle. That's basically what angular displacement is. It's a measure in the expression of an angle, usually. The angle is what this means, angular displacement of the movement of a thing from its original place, as we explained. However, the more technical definition that you see is actually going to be, it's in general technical, but basically it is a definite, specifically that means it is a definite amount of rotation about a specified axis. So that means that the defined amount is going to be 30 degrees. So it is the amount of a defined amount, which is basically in 30 degrees of the rotation. Our rotation in this situation is this would be the rotation about a fixed axis. This here is going to be considered our fixed axis, or the fixed point. So now that we have discussed the meaning of angular displacement in a general context, the point of this video is that we will talk about the meaning in the context of transformers. That is the meaning of angular displacement in the context of transformers. So again, just as we did previously when we were talking about the dictionary definition, we stated that angular displacement, we broke it down, and we will do the same thing here. However, will be in the context of transformers. So angular basically means the angle of. More specifically, it means the angle of. Displacement is the movement between the secondary voltage configuration with respect to that of the primary of a polyphase transformer. So, in the context of transformers, angular displacement means the angle of the movement between the secondary voltage configuration with respect to that of the primary voltage of a polyphase transformer. That is what angular displacement means with regards to transformers. Now, something to highlight here is configuration. What is meant by configuration? Configuration means, for instance, a delta. So that means that you have the transformer connected in delta on the primary and delta on the secondary. Similar to this situation. This means that, or another example, we have delta on the primary and Y on the secondary. These are the equivalent configurations, meaning the configuration of the delta, the configuration of the Y or the star. On transformers, the deltas, and it's customary that the delta is represented by a triangle, similar to the Y. The Y is represented by a star, if you will. Now, when we say transformer, a transformer is basically the function of this device or equipment or apparatus. Transformer is not necessarily a definite terminology, but in our context, we are talking about the apparatus, basically a thing, usually what we consider a transformer to be, is basically it consists of a core, consists of windings, and it is enclosed inside of an enclosure. That's usually what we mean when we say transformer. There are many types of transformers, but particularly speaking, we're talking about general transformers for the transformation, that is, of voltage. So that means transformer in this terminology is the transformer for the transformation of voltage and current, actually, for voltage and current, if you will. Sometimes a transformer may transform the voltage. It may step up or step down the voltage. It may keep the voltage constant. It may affect also, the current usually is going to also be affected depending on the type of transformer. So with that being said, a transformer in general, this configuration could be made up of units that are connected together that form a single transformer. So the term transformer refers to both polyphase and single phase units. However, in the context of angular displacement, we know that we are referring to polyphase units, so therefore we are excluding single phase units. With that being said, it is of our interest to mention briefly when we stated the exclusion of single phase units and the confirmation of the polyphase units for the angular displacement. This is a basic diagram of a transformer. That is, this would be a single phase transformer. It consists of a core and the primary and the secondary winding. In reality, transformers are not necessarily designed this way. However, this illustrates the basic principle. That is, it is adequate in illustrating the basic principle of the operation of the transformer. So in this situation, because this is the primary, we will consider this to be P and we will consider this to be S. So we have a primary and we have a secondary. The voltage which would be applied across this these two terminals here, as we would say, let's say for instance, this would be the EP, which is the E primary, and we will call this one the E secondary. If, for instance, voltage is applied across this primary, there will be a force which links the secondary. Supposing, for instance, that we have a switch in this location. If the switch was open, there will be no current flow. However, once this switch closes, there will be a current which flows in the primary of this transformer. This current is what will supply, supposing that the secondary is open. In the instance that the secondary is open, this current will supply only a magnetizing current. There will only be a magnetizing current. We will call this current IA, which passes here. If we consider this current to enter into this direction, then we have it that the flux will be in the direction that the thumb points. That is, in this direction. We will denote flux by that symbol. Therefore, this flux will travel, and it is obvious that if the current is entering in this direction, that means it flows out in this direction. For the secondary side, the flux will pass in this direction. Therefore, according to this right hand, that means that the current will be in the direction of here. So if that is if the switch is closed. But because the switch is open, we will not have any current flow. But this is just to illustrate the principle. However, even if the switch is not closed here, there will be voltage across the secondary side. As we stated, which links the primary, the secondary, and the primary is the flux. That is that in a single phase setup, there is no difference between the primary and the secondary voltage as far as angles are concerned. That is, if for instance EP actually comes from A phase. Supposing that A phase is at 0 degrees. If the primary voltage is at 0 degrees, the secondary voltage will be at 0 degrees. Usually it will be slightly smaller in magnitude. We can construct a diagram to illustrate these principles easier. We have it that our primary voltage will be represented by EP. The voltage which is on the secondary side, that will be produced on the secondary side, will be in an opposite direction to that of the primary. So we have it that this will be our ES, meaning the voltage on the secondary side. That voltage on the secondary side will also be in phase with another voltage, which is about equal in value to that on the primary side. This we will call the EMF, which is the counter EMF. As far as the flux is concerned, this value, this flux here, it will be 90 degrees approximately displaced from that of EP, which is the primary voltage. So therefore it lags the primary voltage by 90 degrees, and it will lead the secondary voltage in the counter EMF by 90 degrees. As far as the current IA, given in the condition that we do not have any load on the secondary, the current IA under this condition will be in phase with the flux. It will be in phase with the flux because this current supplies the flux. This flux, the same flux which is induced, the same flux which cuts the primary, cuts the secondary, whatever cuts the secondary will also cut the primary. And therefore, we will have a relationship between a single transformer, as in the instance of a single phase transformer. We will have the resultant situation. The reason why we mention this here is that it is clear from this basic understanding that we know that There is no angular displacement when we are talking in reference to the single phase transformer. With that being said, because the same flux that is from the primary will also cut the secondary, it means that the voltages from the primary and the secondary will have the same relative location. That is that each of these lines are developed. This line is developed by a transformer which is being cut by, or if you will, a coil which is being cut by A phase, this one. This one is being developed by a transformer which is being, or a coil which is being cut by B phase, and this side is also being developed by a transformer which is being cut by the flux of C phase. So based on this definition, and now that we have covered the meaning of angular displacement in this context, we know that the question becomes that we are concerning ourselves with what is the angular displacement between, that is the movement between the secondary voltage configuration with respect to that of the primary voltage configuration. What is the angular displacement between a delta delta, for instance, or a delta Y, for instance? Here, there are generally two possibilities. Similar to here, there are generally two possibilities. In this instance, the angular displacement will be 0 degrees. In this instance, the angular displacement will be 30 degrees. We will get into the particularities of how this angular displacement is 0 and how this angular displacement is 30 degrees. It is very important for us to make the distinction between two matters. What angular displacement is not. Here is an example of what angular displacement is not, or what it does not refer to in this context. So, as we mentioned before, angular displacement is the movement of the configuration. It is the movement between the secondary voltage configuration with respect to the primary voltage configuration, that is. We have also seen that the original definition can also be traced with the technical definition as far as transformers in the context of transformers. So, as we can see, we mentioned that in the context of transformers, that the displacement portion is talking about the configuration of the secondary with respect to the primary, the movement. And as we can see, we can trace that the similarity here is also a movement. Here, this is considered the voltages which are related. So, with that being said, as was mentioned previously, angular displacement is not this relationship. As it states here, angular displacement is not the voltage difference. It is not the difference between the line voltage and phase voltage of the secondary. Rather, this is called the vector relationship of the line and phase voltage. I will explain what that means. In this situation, we have a Y. We will consider this to be A, we will consider this to be B, and we will consider this to be C. In our instance, this will be considered our positive direction. If we test from here to here, this will be considered whatever this phase value is, similar to B and similar to C. They are all equal. They are displaced by 120 degrees. This is considered phase voltage. That is the voltage from, we will consider this point to be N. That is the voltage from A, or the voltage from N to A, if you will, or you can say A to N. The voltage from A to N is considered phase voltage. We use EP for E phase, or phase voltage, or electromotive force of the phase. Similar to a Bn, so Bn equals also the phase voltage. And the same for Cn, which also equals the phase voltage. That is, all these phase voltages are equal. We could have written them as An equals Bn equals Cn, if you will. So, with that being said, we have our phase voltage and we have what we call the line voltage. This is considered our line voltage. Line voltage and phase voltage. The line voltage, we know, is the phase voltage multiplied by the square root of 3. How that is because if we consider this to be a direction in which it would be considered plus, if we trace in this direction and then we come through this direction, if we are to measure the line voltage, which between phase A and phase B, that is the voltage AN to the voltage BN, we have that it would be plus A minus B. This represents phase voltage of A. This represents the phase voltage of B. However, it is in the opposite direction. So we consider this to be minus B, or minus Bn, if you will. This is considered minus Bn. So we have that An plus negative Bn, so plus minus Bn, equals this line voltage, which we can consider this voltage to be voltage E A B. This would be considered voltage EAB. The important part here is that these voltages are all related by one relation. That relation is by the secondary. The secondary, that is the secondary of the transformer, will output phase voltage if it's a star connection. In the star connection, this connection, it will output phase voltage. When you test between A to N, there will be phase voltage. However, the testing between A to B will be what is called line voltage. The relationship of this diagram is that this is a diagram that refers to, as was mentioned, the vector relationship of the line and phase voltage. That relationship is 30 degrees. That is that the line voltage is behind the phase voltage by 30 degrees. This is not what we call angular displacement when we are referring to the angular displacement of the transformers. This is called the difference of the vector relationship between the secondary side, or if you will, primary side, but here we're going to talk about the secondary side. This is the difference in relationship between the phase voltage and the line voltage, not what we call angular displacement. I will now proceed to explain what does angular displacement mean. Previously, we explained the difference between what angular displacement is not. We said that it is not the difference between phase and line voltage. Rather, this is considered the vector relationship of phase and line voltage. Therefore, according to this definition, the difference, the angular displacement is the difference between the secondary voltage configuration with respect to the primary voltage configuration. We will now proceed into explaining this subject. Here we have a configuration we consider to be delta-delta. That is, the connection on the primary side is a delta and the connection on the secondary side is a delta. That is denoted by the capital letters and the lowercase letters, or the capital letters being for the primary and the lowercase letters being for the secondary, and the difference in color. We will keep this consistent throughout. The question here is, what is the angular displacement of the primary side of this transformer, of the secondary side of the transformer with respect to the primary side? Or you could say it the opposite way. However, the definition states particularly that the secondary is referenced to the primary, but the displacement would be the same regardless. Eventually, we will explain this further. So we have it that the displacement is 0 degrees here. I did explain that previously when we looked at this. I did show that, previously when we looked at this example. But I will explain it further here. How is it that the displacement between a delta is 0 degrees? Well, that's obvious. That is because if we look at the position of A and the position of A on the secondary with respect to the position of A on the primary, we see that it is in the same position. Therefore, we consider this to be 0 degrees displacement. Now, one thing that's very important is that how is it that we know that what is it that we are referencing as far as the displacement is concerned? As we mentioned, it is basically the location of each face. So therefore we have it that A and B are considered to be 0 degrees displaced. A situation where we will see displacement is in this situation. So we have it that A, as we mentioned previously, the primary is in purple and the secondary is in orange. As we mentioned, the capital letters will denote the primary and the lowercase letters will denote the secondary. The question is that what is our angular displacement with this configuration? As we see thus far, the comparison is between the primary and the secondary of the same transformer. Here we have never mentioned that the comparison is between the secondary is between the line voltages and phase voltages. The comparison, as we said here, is still going to be between the primary transformer, primary side of the transformer, and the secondary side. So here, the resultant voltage configuration of the primary side is this configuration. Similar to the secondary side, they are both delta connections or delta configurations. But if we go back to the original definition, a definite amount of rotation about a specified axis. Or if we go even to the more specialized definition, it's basically the movement between the secondary voltage configuration with respect to that of the primary of the transformer. So our definite amount of rotation is what is in question. The question is, what is our definite amount of rotation? That is measured in degrees. So it's some value measured in degrees. The amount of rotation about this specified axis, this is our specified axis. So therefore, we see that if it is seen that the primary side, first A, points in this direction, correct? Then what has happened is it is as if the secondary side has been rotated. The secondary delta has been rotated and flipped in a totally opposite direction. Okay, so we have it that this is our fixed point. Our fixed point is where we are referencing to, meaning we will keep the triangle of the delta, or the delta, rotational on it and fixed to it, and it's about that axis in here. So if we see if we construct a line from the fixed axis all the way to the terminating point of where A would be, the corner of A, we see that the rotation from A, the original location, which is the location of the primary, to the location of the secondary, which would be this location here, is going to be half a rotation. Half a rotation with respect to the delta as we see. And half a rotation, if one full rotation would be 360 degrees, half of that rotation is going to be 180 degrees. So we have it that our angular displacement of this configuration, so therefore the angular displacement of this transformer is 180 degrees. That is the difference between the secondary configuration with respect to the primary configuration, or in a more literal terminology, it would be a definite amount of rotation. A definite amount of rotation is definite. This is defined. A defined amount of rotation about a specified axis, and the axis is this. So far, to this point, we have discussed two different cases. That is the case of the delta-delta, which has 0 degrees displacement, angular displacement, and the also delta-delta, which has 180 degrees displacement. The question then becomes, what if we have a combination of different, instead of the configuration being the same, the configuration would be different. Here, this was easy because we have the same configurations laid on top of each other. So it's easy for us to see where A's position went with reference to the initial position of A with regards to the resultant position. That leads us to our third case. In the case of a situation where you have a delta primary and a Y secondary, as we see, as represented by the diagram, if we see, as we see, for instance, the secondary is represented by lowercase and the primary is represented by uppercase, we can see that it's not as simple, as to set the, for instance, in a delta situation where we set the delta in the delta to see if there was any displacement. However, with this situation, there has to be an equivalence. In the first two cases, the equivalence was the actual configuration. They were equivalent by configuration. That is, they were similar by their configuration. As we see, delta-delta is similar in their configuration. Here, a Y-delta is two completely different configurations. So therefore, we have to have a similarity between the two in order to compare them with regards to their actual configurations. As we know, we can see a few similarities with regards to the individual coils which will make up the configuration. We see here that the line on the primary side, which is the primary side of the transformer, is parallel to that of the secondary. So that means that this line here and this line here will share the same exact coil, if you will. As far as this side, these will also share the same coil. As far as C and C, they will also share the same coil. Now, as far as the angular displacement is concerned between A, capital A and lowercase a, that is the primary A and the secondary A, we have to make an equivalence. If we recall back to the definition, it is the movement between the secondary voltage configuration with respect to that of the primary. By looking at this diagram, we can see, because it is labeled, that A, the initial position of A, was in this position. So we will consider this to be the initial position of A, because this is the primary side. This is the initial position of A. The initial position of A, going back to the basics as we discussed in the beginning, as we can see, the same logic still holds. we see that this is the initial position. This is the initial position. So therefore, it is as if A has rotated to this position. So the initial position of A was at this location. Now its position is at this location. Therefore, in this situation, we have a displacement. The question is by how much, and that displacement is 30 degrees. In this case, the primary side is lagging the secondary side. That is that the secondary side is leading the primary side. And as I mentioned previously, that the primary side is lagging the secondary side. However, when we denote the degrees, the question becomes, do we consider this to be plus or do we consider it to be minus? In this situation, this would be plus 30 degrees because this will indicate that the secondary side is leading the primary side. As we remember that it is with respect, the secondary voltage configuration with respect to the primary. The secondary voltage configuration with respect to the primary voltage configuration is leading by 30 degrees. Similar, if we compare any other angles, we can see that this original location of B is basically lagging. So this leads the original location by 30 degrees. Similar here, the original location of C is here, and it has leaded the initial location. The initial location is lagging the secondary location, the voltage of the secondary side, by the same amount of 30 degrees. With that being said, this is what we consider to be the angular displacement. In other words, to sum everything up into one simple statement, if you will, the angular displacement, as we stated before, is a definite amount of rotation about a fixed axis. Here, we see that the rotation is on this fixed axis, which is here. The initial location is here. The secondary side has been rotated here. Because, why? It is because the initial location of the original equivalent voltage of A is rotated to this location. As we see thus far, the comparison between each of these cases, meaning all three of these cases, the line voltage and the phase voltage was not compared. Rather, it is the configuration between, meaning we did not compare only the secondary voltage and phase and line voltage. We are comparing the configuration to the primary configuration. Similar to this instance, we have compared the configuration to the secondary configuration. Technically speaking, this is a line to neutral voltage. This is a line to neutral voltage. This is what angular displacement is referring to in reality. It is referring to the line to neutral voltage of the delta and the line to neutral voltage of the star. The line to neutral voltage in this instant is the if you will, imaginary. The imaginary line in which would be constructed to compare the delta with the star.